Okay, so let us continue with our topic that is real numbers. We were solving few problems that were based on Euclid's division algorithm in the previous class. Now let us continue with the problems based on the Euclid's division algorithm. So let us take the next question, that is, what is the largest number? What is the largest number? What is the largest number? What is the largest number that divides 6 to 6, 626, comma 3127, 3127, comma 15628, 15628, and leaves remainders and leaves remainders 1, 2, and 3 respectively. 1, 2, and 3 respectively. Okay, that is our question. Now let us come to the solution of this question. How we will solve this question? We have to find the largest number that will divide these numbers and leaves remainders 1, 2, and 3 respectively. Okay, so here we can write clearly the required number clearly the required number is the HCF of the numbers that is 626 minus 1 is equals to 625, then 3127 minus 1 is equals to 3126, and that is 15628 minus 1 is equals to 15627. Okay, now using Euclid's division algorithm lemma to find the HCF of all three numbers. Now we can write using Euclid's division lemma. Euclid's division lemma to find the HCF. So we will proceed like this. First of all, we will find the HCF of. First, we are finding the HCF of, that is 3126. That is sorry, here we have made some mistake. So let us rectify it. In the first case, remainder was 1. So that's why we have placed 1 here. Now in this case, remainder is 2. So that's why we'll place here. Okay, so this number comes out to be, so that is 3127 minus 2. That value comes out to be, that is equals to 3125. So here we can put 3125, and here we can put this minus 3. In this case, remainder was 3. That is 15625. Now we want to find the HCF of 625 and 3125. HCF of 3125 and 625. For it, we will divide 3125 by 625. Okay, so quotient is 5 and remainder comes out to be 0. Now from here we can say that HCF of these two numbers is equals to 625, because at this stage remainder is equals to 0. Now let us find the HCF of 625 and 15625. So we will divide 15625 by 625. Okay, this time the quotient is equals to 25, and again the remainder comes out to be 0. So here HCF is equals to 625. Okay, so by this way we can say that HCF of all these numbers is 625. So required number is 625. That is the answer. Now Let us solve few more problems that are based on we can say them all as the word problems that are based on the HCF of the two numbers. Okay, so let us write down the one more problem. That is our second question. So we can a merchant has 120 liters of oil, 120 120 liters of oil of one kind, comma 180 liters of another kind, and 240 liters of third kind. Now he wants to sell the oil. He wants to sell the oil by filling the three kinds of by filling the three kinds of oil in tins of equal capacity. In tins of equal capacity. Okay. Then question is, what should be the greatest capacity of such a tin? What should be the greatest capacity? What should be the greatest capacity of such a tin? Okay, so that is our problem. Now, since the greatest capacity of a tin that required the such conditions will be the HCF of all three numbers. So let us come to the solution of this question. How we will solve this question? Okay, greatest capacity of a tin, we can write, that is greatest greatest capacity greatest capacity of a tin will be the HCF of 120, 180 and 240 and 240. Okay, so let us find the HCF of 120 and 180. So for this purpose we will divide 180 by 120. So we can write like this: when 180 is divided by 120, quotient is 1 and remainder is 60. In the second step we will divide 120 by 60, quotient is 2 and remainder comes out to be 0. So HCF of these two numbers is equals to 60. Now we will find the HCF of 60 and 420, 240. In the next step, HCF of 240 and 60. Okay, so for this purpose we will divide 240 by 60 into 4 and remainder comes out to be 0. So HCF of these two numbers comes out to be 60. Okay, so our answer is, the greatest capacity. So the greatest capacity of tin. So the greatest capacity of tin, that is greatest capacity of tin, okay, is equals to 60 liters. That is our answer. So by this way we will solve this problem. Now let us solve few more problems that are based on the finding the HCF of the two numbers. Okay, so let us take one more problem. That is, let us come to the next type of problem. That is our third question. In a morning walk, in a morning walk, three persons step together, step up together, step up together. Their steps measures, their steps measures, their steps measures 80 centimeters, comma 85 centimeters and 90 centimeters. Okay, respectively. Okay. Now our question is, then what is the minimum distance? What is the minimum distance? What is the minimum distance each should walk? What is the minimum distance each should walk so that they can cover the distance, so that they can cover the distance in complete steps. They can cover the distance in complete steps. Okay, that is our question. Now again come to the solution of this question. How we will solve this question? Since required minimum distance each should walk so that they can cover the distance in complete step is the LCM of all three numbers. So we can write that is required minimum distance each should walk each should walk so that they can cover the distance, so that they can cover the distance in complete step in in complete step in complete step is the LCM of 80 centimeters, 85 centimeter and 90 centimeter. Now let us find the LCM of all three numbers. For this purpose, let us factorize all three numbers. How can you factorize? Means we can write 80. 80 can be written like this. That is 2 to the power 4 into 5. Then 85. 85 can be written as, that is 5 into 17. Finally 90 can be written as, that is 2 into 3 square into 5. Okay. Now LCM of all three numbers is equals to, that is 2 to the power 4 into 3 to the power 2 into 5 into 17. So this value comes out to be 12240 centimeter. Okay, or it can be also written as 122 meter 40 centimeter. So that is the minimum distance each should walk so that they can cover the distance in complete step. Let us solve one more problem. We are given, that is again based on the HCF and the LCM of the two numbers. That is our fourth question. We are given if HCF of P comma Q is equals to 12. Okay, then P into Q is equals to 1800 N. Okay, and where N belongs to natural numbers, N is any natural number, then find the LCM of P and Q. Then find the LCM of P and Q. Now let us come to the solution of this question. In this question, we are given the HCF of these two numbers is equals to 12. So we can assume the numbers like this. P is 12x and Q is 12 into y. Definitely both P and Q are the multiple of 12 because 12 is the LCM of these two numbers. Okay, where x and y are the co-prime. Now, according to the question we are given, it is P into Q is equals to 1800N. If you substitute the values of P and Q, that is 12x into 12y is equals to 1800N. Okay, if we simplify this, then we'll get the value of x into y. Value of x into y comes out to be, that is 25 n upon 2. That is our first relation. Okay, now that is our first relation. Okay, now we know that the LCM of these two numbers, okay, since LCM of these two numbers is equals to, okay, we have one more property, that is LCM into HCF of these two numbers is equals to product of the two numbers. If we substitute the values, then 12 into x into y comes out to be, okay, then this equals to, that is 12 into 25 n upon 2. And if we solve this equation, okay, if we solve this equation, then LCM of these two numbers comes out to be, that is 12 into 25 into n divided by 2. So LCM of these two numbers is equals to 150n. Okay, now definitely LCM will be multiple of 150. LCM is multiple of 150. That's why we can get that 900 is the LCM of these two. Is the LCM of these two numbers. Okay, so by this way we use the relation. That was our second relation. Okay, we have substituted the value. It is LCM of these two numbers is 12. Okay, by this way we can solve the question. Okay, so that's for today. We'll discuss few more problems in our next class.